Okay, welcome back to another Physical Sciences 3 lecture. In this video, we're going to cover example 5 on page 32. And this is continuing on from the frictional forces and normal forces video from last time. Okay, so in this example here, we want to draw force diagrams draw diagrams showing the forces acting on a skydiver jumping out of a hot air balloon at the moment the skydiver leaves the balloon, a short time after the skydiver leaves the balloon, and once the skydiver has reached terminal velocity. Okay, so the moment the skydiver leaves the balloon, velocity isn't very large. So let's draw in our skydiver. Just going to make them a box as well. So we've got our skydiver, and you can be a bit more artistic than me if you feel like it. So we always have our force of gravity, and I like to draw that from the middle. Force of gravity, and the moment it leaves the balloon, the velocity is small. Okay, so velocity is small, so that means that the resistances, so this is the F air resistance, or the friction, which is equal to frictional forces as well, or drag, if you like to call it drag, that's fine too. But the air resistance is very small. It's almost negligible. Okay, so there's not much air resistance in there. As the skydiver increases, the force of gravity remains the same, but then the air resistances are slightly bigger. Okay, so a short time after, that's because velocity is larger, or the speed is larger. Okay, so, and as the speed gets larger, the air resistance gets larger as well, until it reaches terminal velocity, Fg. So Fg stayed the same each time, and this time the air resistance is equal to the force of gravity. Okay, so this terminal velocity means when the forces are balanced. Terminal velocity is when forces are balanced. Okay, so that means that there's no more acceleration happening. So terminal is when forces are balanced, so there is no more acceleration. So there's no more acceleration. So, and it's when F air, there's no more acceleration when the air resistance is equal to gravitational forces. Okay, so we just have to make sure that we're drawing our vectors in and making sure that they look equal and indicating that they are equal here. This one, with the first one, you could almost neglect to put in the frictional forces if you liked, because there's barely any, because it's just immediately left and its velocity is very low. Okay, so the key thing is, as velocity increases, the air resistance increases. So the air resistance increases until it matches the force of gravity.